In this video, I will do a quick hypothesis testing overview. What is a hypothesis? A hypothesis is a claim or an assertion about a population parameter. We can do hypothesis tests about the mean. For example, the mean monthly cell phone bill in this city is $42. Or we can test about a population proportion. The proportion of adults in this city with cell phones is 0.88. The null hypothesis states the claim or assertion to be tested. For example, the mean diameter of a manufacturer bolt is 30 millimeters. You denote the null hypothesis by H naught, and then you put down what you're testing. So in this case, we're testing the mean is equal to 30. The null hypothesis is always about the population parameter. It's never about a sample statistic. So you would never use X bar when you're testing for the mean, because X bar deals with the sample. Mu deals with the population. You always begin with the assumption that the null hypothesis is true, and that's similar to the notion of innocent until proven guilty. It represents the current belief in a situation, and it always contains an equal sign. You can also use less than or equal to, or greater than or equal to. But whatever the case, it always has an equal sign in the null hypothesis. Your null hypothesis may or may not be rejected. The alternative hypothesis is the opposite of the null hypothesis. For example, the mean diameter of a manufactured bolt is not equal to 30 millimeters. So the null hypothesis is denoted by H1. You sometimes see it written with HA, with a subscript A. So in this case, the mean is not equal to 30. So you will use an equal sign with a slash through it. And it challenges the status quo. So these are different types of hypothesis tests. You can have a not equal to, a greater than, or less than in your alternative hypothesis. This here is what you call a two-tailed test. Not equal to is two-tailed. Over here, these next two are called one-tailed tests. Okay? This second one is a right-tailed test because your alternative hypothesis, the inequality sign is pointing to the right. And for the third one, it is less than, so we call that a left tail test. You can also call this like a lower tail test. You can also call this an upper tail test. But whatever the case, it's one tail. As I stated earlier, your null hypothesis will always have an equal to sign. So you don't necessarily have to put this when you do your test. You can always just use an equal sign. It's always an equal sign for the null hypothesis. But less than or equal to or greater than or equal to, depending on the test, will be okay. So once you set up your hypothesis, you're going to sample the population and the sample mean. Sample the population and find the sample mean. So the goal is to see whether or not you should reject the null hypothesis. If you reject the null hypothesis, that means you have sufficient evidence to support the alternative hypothesis. If you do not reject the null hypothesis, you do not have sufficient evidence to support the alternative hypothesis. To determine when to reject the null hypothesis, we select the significance level alpha. The significance level specifies the size of the region where the null hypothesis should be rejected. We call this the critical region. So if you look at this graph here, this is a two-tailed test because our alternative hypothesis has not equal to. We split the level of significance alpha into the two tails, so we divide it by 2. So the blue region will be considered your rejection region. Okay? Your critical values is what separates the rejection region from the non-rejection region. And this one, this is a lower tail test. As you can see, our rejection region is over here to the left, as this is a left tail test because we have less than in the alternative hypothesis. Our rejection region will be alpha. So if you notice, we did not have to split alpha. The alpha would be solely in the left tail. The same thing goes with the right tail test. We have a right tail because our alternative hypothesis is greater than. Our rejection region will be in the right tail. Once you get your sample information, you will go ahead and calculate a test statistic. And depending on the test, if your test statistic falls within the rejection region, then you would reject the null hypothesis. Okay? And then that means you have enough evidence to support the alternative hypothesis. Your test statistic may fall in the do not rejection region, and then if that's the case, you would not have enough information to support the alternative hypothesis. Another way you can do a hypothesis test is with the p-value approach. What will happen is you'll take your p-value, you'll calculate it, and you will check to see whether or not it's less than or greater than your significance level. If your p-value is less than the significance level, you reject H0. If p-value is greater than or equal to the significance level, you do not reject H0. And an easy way to remember this is the saying, if the p is low, the null must go. If the p is high, the null must fly. Okay, so if the p is low, the null must go. That means your p-value is less than the level of significance, and the null hypothesis must go, meaning that you reject the null. If the p is high, that means your p-value is greater than the level of significance, and the null must fly. The null must fly means you do not reject the null hypothesis. So in my upcoming videos, I will show you how to calculate the test statistic and determine whether or not you should reject the null hypothesis. We will also look at the p-value approach.